Choosing the perfect weather condition is a key to success with the long-range TLT experiments. Fog is the most obvious factor that affects the visibility of a laser. In thick fog, you may have less than 100 meters visibility. High humidity also decreases the distance of the laser light. Strong winds cause turbulence over the lake and create unstable layers of air with different refractive properties. As those layers are rapidly mixed by the wind, the observer may see the laser beam dancing wildly as if the laser operator was rapidly waving the laser in hand. Timing is everything. Ironically, the conditions FECORE sought manifested less than 48 hours later. Sandor came back to the lake, and this time he was able to walk over the now frozen bay. SALAD upgraded with automatic GPS targeting system.
FECORE established at Lake Balaton that targeting the beam to the observation location is the most difficult part of the TLT method. A super-accurate laser aiming device is able to aim the laser in very fine increments. But how would the team know exactly where to point the beam? It was like playing darts blindfolded. The team had to find a solution for locating the target position. Mike came up with a perfect solution and worked to improve the method of aiming the SALAD. He created software that calculated a bearing change based on 3 GPS locations. With the new GPS update, the SALAD operator could input coordinates for a new target location and the laser would point directly to that exact location. There was now a procedure in place to calibrate the actual alignment of the SALAD first.
This is the actual interface of the device. It's got the settings section here where you actually put in the numbers when you're calibrating your device. And it's got a control section here where you actually control the motors themselves with up, down, and left and right. And then it's got a GPS menu here where you actually have 3 fields that you need to put in. And that's the position of your actual laser where you set it up, your GPS location. And then you have the reference location. That's a location that you need in order for the SALAD device to know in which direction it's actually pointing the laser beam. And then you have the target location, and that's the maximum distance that you want to shoot your laser at. You fill in those GPS coordinates, and then you press go to target on this device, and it steers the laser to the desired GPS location.
Before any targeting with the laser can occur, the SALAD needs to be properly set up and calibrated. This process involves careful leveling of all parts of the device and laser. To do this, the SALAD is put down on a platform and each of the 4 legs must be adjusted individually to make sure all beams are level. After the device is leveled, the laser beam must also be leveled. This is done in conjunction with a laser level device, which is placed directly behind the laser. The difference in height of the laser level and the laser itself can now be adjusted to be the same across the maximum distance available at that location. Then the setup is ready to start with our newly developed GPS-based terrestrial laser targeting procedure.
The Lake IJssel, Netherlands measurements. After the 2 measurements at Lake Balaton, FECORE performed 5 TLT measurement over Lake IJssel. An interesting feature of the Netherlands is that the lands surrounding the lake are almost all below the level of the lake. On April 7, 2018, at about 7 o'clock p.m., the FECORE team of Mike, Jeroen, and Patrick began setting up the SALAD on the balcony of a restaurant in Enkhuizen, Netherlands. This was the laser location for all subsequent measurements on Lake IJssel. The setup was completed around 10 o'clock p.m. The laser height was 2.85 meters above the surface of the lake. This location was well known by Mike, who had been there many times over the years. The choice for the reference position was a small stand of trees about 25 meters tall on the opposite shore. Mike had often wondered how it was possible to see the trees over such a great distance. The team chose this location as the Target 1 reference position for calibrating the SALAD because Mike had been to the trees previously, so he knew the location had good access to the lake for an observation. This was FECORE's first chance to use the new GPS TLT system. So in addition to attempting to measure the lake surface for geoid comparison, the team was also testing this new method. Measurement 3, Lake ISIL Target 1. On April 8, 2018 at 1 o'clock a.m., the blue laser was on the salad at 2.85 meters or 9.35 feet above the lake surface. It was seen at the Target 1 position, 21.26 kilometers or 13.21 miles, at a height of 1.2 meters or 3.94 feet above the lake surface. It took less than 60 seconds for them to see the source of the laser at the Target 1 location.
Can you guys see it?
Yeah, I see it. Yeah, it's there. Okay, yeah, we can see it really well there.
Can you see the reflection on the water?
I'm gonna zoom out.
Yes, we do. Yes, we do. Look at that.
Wow.
Oh, man, that is irrefutable.
Yeah.
Awesome.
Oh, I can watch this all day, you know.
This is awesome.
Yeah, this is really awesome.
Look at that reflection. That reflection absolutely caps it.
Yeah.
That caps it. That annihilates any possibility of it being refracted, and that also annihilates any possibility of any convexity.
Yeah.
I mean, you cannot track it with being curved.
The 21.26 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 3 ISIL Lake, Target 1 location of 18.18 meters or 59.6 feet. The camera height was 1.2 meters. The WGS-84 geoid model differed by 16.98 meters in this measurement, which meant 93% of the target hidden height was visible. The lake temperature was 7.6 degrees Celsius or 45.7 degrees Fahrenheit, and the air temperature was 10.8 degrees Celsius or 46.4 degrees Fahrenheit above the lake. The ambient conditions showed the refractive indexes were about the same on both sides of the lake. TLT calculations factor in any variations in recorded data and geoid datum parameters of the WGS-84 mathematical construct. Both target and laser positions are at 0 meters mean sea level. The WGS-84 geoid undulation map shows a marginal 23 centimeters or 9 inches height difference at the two positions. Measurement 4. After the measurement at Target 1, Mike and Patrick drove 30 minutes to the Target 2 location. Target 2 was selected because it would be within 17.5 degrees panning limit of the salad. Since the salad had been calibrated at Target 1, the automatic GPS system now required only a new coordinate to automatically target that position. This was the first field test of the new GPS TLT software, so it was an exciting moment. On April 8, 2018 at 3 o'clock a.m., the blue laser on the salad was 2.85 meters or 9.35 feet above the lake surface. It was seen at the Target 2 position 28.68 kilometers or 17.82 miles away at a height of 0.85 meters or 2.79 feet above the lake surface.
Okay, check this out, brothers and sisters. 28 kilometers in your face.
Wow. Awesome. That is awesome.
My camera is 85 centimeters above sea level.
Look at that. That's amazing. You can see it reflecting off the lake water.
Yeah.
That's astounding.
That's the nail in the coffin.
Yes, it is.
Oh, this is so great, but it's really awesome.
The 28.68 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 4 ISIL Lake Target 2 location of 40.21 meters or 131.9 feet. The WGS-84 mathematical construct differed by 39.36 meters in this measurement, which meant 98% of the target hidden height was visible. 40 kilometers or 25 miles is a very great distance. To perform a 40 kilometer TLT measurement, good atmospheric conditions with great visibility are required. The 40-kilometer measurements were scheduled for April 20th through April 22nd. FECORE members from the Netherlands, United States, Hungary, and Spain on April 20th in Enkhuizen, Netherlands, for the longest distance laser observation over water in history. The team set up the salad with the blue laser. The reference location was set 18.73 kilometers from the salad at target 3. However, the weather was not in the team's favor. During the first night, the humidity was so high that haze reduced the visibility and dimmed the laser, making any measurement impossible. The second night, April 21st, the humidity was low enough that the team located the laser at the target 3 initial reference location.
We just parked here, and it looks like we're gonna spend the night here. So we're gonna spend the entire night looking for the laser.
They calibrated the GPS TLT system and performed measurement 5 at 12 o'clock a.m. on April 22nd. Measurement 5, Lake Isel, Target 3. On April 22, 2018, at 12 o'clock a.m., the blue laser was on the salad at 2.92 meters, or 9.58 feet, above the lake surface. It was seen at the target 3 position, 18.73 kilometers, or 11.64 miles, away at a height of 1.6 meters, or 5.25 feet, above the lake surface. The 18.73 kilometer calculation based upon the WGS-84 geoid model results in a target hidden height for measurement 5 Isel Lake target 3 location of 12.504 meters or 41.024 feet. For measurement 5, the WGS-84 mathematical construct differed by 10.904 meters, which meant 85% of the target hidden height was visible. FECORE examined the effects of refraction through the gradients in the air by adjusting the beam vertically. It was concluded that with the present ambient conditions at measurement 5, the beam was refracted downward by a maximum of 1/100th of a millimeter. Measurement 6. The team moved to the 40-kilometer location, or target 4. At 40 kilometers, finding the source of a laser beam with the naked eye is almost impossible, especially if there are other light sources on the horizon. A telescopic camera was the solution to distinguish the laser from the other lights. Measurement 6, Lake Isel, target 4. On April 22, 2018, at 2:19 a.m., the blue laser was on the salad at a height of 2.92 meters or 9.58 feet above the lake surface. It was seen from the target 4 position 40.14 kilometers or 24.94 miles away at a height of 1.5 meters or 4.92 feet above the lake surface. The 40.14 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height of 90.81 meters or 297.33 feet for measurement 6 Lake Isel target 4 location. The WGS-84 mathematical construct differed by 89.31 meters in this measurement, which meant 98% of the target hidden height was visible.
Yesterday we had a little bit of bad luck because the beam of the light was not so good visible with the camera. We could definitely see it with the naked eye, but to catch it on camera it was really difficult. So we have adjusted some things for today, and we are truly expecting better results.
Yeah, but the intensity is going down.
Yeah, that's going way down.
Okay, just put it one step up, Sandro. Okay, one more. Put the steps.
Wow!
Put the steps on.
I think I just caught that.
250,000. One more. One more. Okay. Yeah, one more.
Maybe one more. Maybe. Oh,
yeah, one more. One more. You got it?
I could tell. I was looking right at it. More down.
Down?
Yep.
It's going up.
Get one now. Get one up.
Yeah, just I think we're looking at it. Yeah. With the naked eye.
FECORE examined the effects of refraction through the gradients in the air by adjusting the beam vertically. It was concluded that with the present ambient conditions at measurement 6, the beam was refracted downward by a maximum of 0.064 millimeters.
We were shooting the laser 40 kilometers across the lake. We did find it on the target location, but it was already getting light, so the intensity of the beam was almost not visible anymore. And we had some issues with finding the right orientation of the beam itself. So now that we know where to actually point it, we're going to try it again today to get it on tape.
Measurement 7. In the evening of April 22nd, the team returned to the Target 4 location. They worked late into the night taking many pictures. Rick's camera was set to take one picture every 5 seconds.
So the source of light, whatever's going on top of the water, you're not going to be able to see it. There's too much humidity, the water's blowing, it's spraying.
Yeah, and it's windy on your side, right?
Oh, it's real windy on our side.
Yeah.
Okay, buddy.
Patrick, can you see anything?
Right. So, there we go.
Nothing at all?
There's just not enough light coming off from
First
it.
of all, there's too much light pollution coming at us too close. Then it'll knock that out.
Measurement 7, Lake Isel, Target 4. On April 22nd, 2018, at 11:20 p.m., the blue laser was on the salad at 2.92 meters, or 9.58 feet, above the lake surface. It was seen at the Target 4 position 40.14 kilometers, or 24.94 miles away at a height of 1.5 meters, or 4.92 feet, above the lake surface. The parameters and outcome of measurement 7 was the same as the one from the previous night. The only difference was the maximum refraction of 0.133 millimeters caused by the slightly different ambient conditions. The observers should not have seen the laser at any height below 89.3 meters, or 293 feet, but the beam was recorded from a height of 1.5 meters, or 4.92 feet.
Stop. Okay. Bring it down now. The laser down.
Going down.
Zach, if you want to record some of this, you can. I know you're not. I'm trying to record something. Okay, you still coming down? Yep. Okay, stop. Go back up a little bit.
Conclusions.
The results of the 7 TLT measurements indicate that these two lakes do not conform with the WGS-84 mathematical construct and that they lack the predicted convexity. The testing results agree with the analysis of error sources. In summary, the testing results of the lake surfaces were plus or minus 0.2 meters and the relative accuracy was within 1%. In conclusion, the TLT measurements met the accuracy of the experiment design requirements and provided a definite deliverable output.